Welcome to Control System classes. The topic for today's discussion is effects of zeros in time response analysis from electrical engineering talk. The explained representation of a first order system with pole at -1 and for second order system with pole at -5 plus or minus j 1.33 has been shown here. Now to this original system, we are going to add some five zeros. The zeros are at s is equal to -20, -2, at 0, at +2 and +20. The mathematical calculations have been done here. And the function, it is observed that the initial final value becomes 1 when the zeros are located in the LHS, when the final values becomes -1 when the zeros are located at RHS, and also the final values become 0 when the zeros are located at the RG. And the MATLAB output is also depicts the same. It also says it also controls the same results, and this is the response without any zeros. With adding 0 at the location s is equal to -2 will make the initial magnitude to jump out, and hence it reduces the rise time. And also this is the response at if a 0 is added at the origin, so it means it has initial transient response and the final value will settle at 0. And these two plots represents the location of zeros at the RHS, and also it has an undershoot. So the graph will shift to the opposite side and it settles at -1. Same can be applicable for the second order system, but it is an underdamped system, so the response will have an underdamped shape and then it reaches the final value. Here also we can see that initial value is 1, the final value is -1. So the conclusion about the effect of 0 to the first order system and second order system is it affects the transient response, it improves the rise time, it reduces the rise time, and hence the response will become faster. It creates an overshoot when the poles are very nearer to the imaginary axis on the LHS, and it creates a larger undershoot when the zeros are located nearby the imaginary axis on the RHS. When the zeros are located in the RHS of the S-plane, you can also call the system as a non-minimum phase system, and this added zeros will not decide the instability, will not make the system to become unstable, but it creates instability problems by increasing the controller gain to be a very large value. Thank you.